Hello everyone! In this video, pag-uusapan natin ng t-test for one sample mean. Magkakompute tayo ng t-test statistics and we will also decide if a certain claim about the population is true or false, valid or invalid, depending upon the computed t-test statistic. Without further ado, let's get this lesson started. So ano nga ba yung tinatawag natin na t-test for one sample mean? Ito ay ginagamit if you are testing a claim about a population pero isang sample lang yung ginamit mo for it. Previously, meron din tayong ginagamit na z-test for one sample mean but it has a different assumption. For t-test, ito yung mga kailangan niyang ma-meet na assumptions bago natin masabi na applicable yung t-test. Una, yung ating population standard deviation, itong ating sigma is unknown, pero ang sample size natin or yung nakuha natin na representative to the experiment is greater than 30. So, n is greater than or equal to 30. If the population standard deviation is unknown, pwede din natin gamitin ang t-test statistic kung merong assumption doon sa problem na yung population natin is approximately normal, kahit pa yung sample space natin is less than 30. So ito yung dalawang kailangang ma-meet. Either of the two can be met para masabi natin that the t-test for one sample mean is applicable sa problem. And by the way, it is important to note that this t-test for one sample mean is different from the other t-test na ginagamit sa ibang study. It is different from independent t-test or dependent t-test. If you want to know more about those kind of t-tests, I will be putting a link sa mga video na yon dito sa upper right corner ng video natin. So, ito ang formula na gagamitin natin throughout the video as we compute for the t statistic. So, ang t natin is equal to the sample mean na mina-minus sa hypothesized population mean. So, sa problem pa lang kailangan marunong tayong mag-identify kung ano yung sample mean at ano yung hypothesized population mean. All over S, S stands for the sample standard deviation divided by the square root of n, where n is the sample size. Additionally, may gagamitin tayo na tinatawag na DF, degrees of freedom. This is computed using n-1. So again, itong DF ay degrees of freedom at gagamitin natin ito when getting the critical t value from the t table. By the way, itong ating denominator na s divided by square root of n, that is also referred to as the standard error. I-present ngayon natin kung ano yung tinatawag na t-table. So what you can see on the screen is the t-table that I am using in my class. So yung first column natin here is the degrees of freedom. Ito yung mga degrees of freedom. At ito namang 0.1, 0.5, 0.25. Ito naman yung mga level of significance. Yung mga rejection region. Etong mga nandito sa body, yan yung mga T values. Na yan yung mga critical na kung saan natin ilalagay or i-compare yung mga na-compute natin na T value. So later, as we go to the different examples, we will use this table. So, ano yung ating decision rule kapag tayo ay gumagamit ng critical t value? So, syempre, meron tayong level of significance. It is always given sa ating problem. At i-compare natin yung t-test statistic, yung na-compute natin, doon sa nakuha natin sa table. Kung ang ating HO at HA is set up like this, ibig sabihin two-tailed yung ating test, ang ating decision rule ay i-reject yung null hypothesis if yung absolute value ng computed t-value ay mas malaki kaysa sa critical t-value. Kung right-tailed naman yung test, ibig sabihin ganito yung setup ng hypothesis natin, less than or equal to sa HO pero greater than sa HA. Ang decision rule natin is reject HO if yung computed value ay mas malaki kaysa sa critical value. And finally, if we have a left-tailed test, it means that for the HO, ang symbol natin is greater than or equal to. Pero sa HA naman is less than. Ang decision rule natin is we will reject the null hypothesis if the T or the computed T value is less than the critical T value or yung ating left-tailed test. If hindi ganito yung mga naging comparison natin ng computed at critical value, we have to accept the null hypothesis. So let's go now to the examples. So for this example, Never Better XYZ, a corporation that produces auto batteries, claims that on average, the better than best batteries last for at least 70 months. A consumer protection agency wanted to know the validity of this claim, so they tested 50 batteries. It was found that the mean life of these batteries is 65.3 months and the standard deviation is 4 months. As we can note here, yung standard deviation of 4 months, that is only for the sample. It's not for the entire population. That is why we will use here t-test. Using 2.5 level of significance, is there enough evidence to validate the company's claim? So we start by highlighting or noting the different values of the variables that we are given with here in this problem. So for the sample mean, nag-test daw sila ng 50 batteries at ang naging mean ng sample na yon is 65.3 months. Pwede nating isulat na lang later yung months basta yung value ay nandito. Ang hina-hypothesize or ang kine-claim na mean ni Never Better XYZ is 70 months daw. Ang sample na standard deviation ng 50 batteries is 4 months. N stands for the sample space, so that is 50 batteries. Ang alpha natin is 2.5%. At ang ating degrees of freedom, sinosolve using n-1. Ang n natin ay 50 minus 1, that is 49. Let's set up the hypothesis. So we write HO and HA. To write HO and HA, you have to look for the claim and identify the corresponding symbol based on the keyword sa claim. So let's go back to the first sentence. Kine-claim daw ni Never Better XYZ na ang batteries ay at least 70 months. And we know, when we are talking about at least, pwedeng higher yung values or equal to. Or in other words, at least is translated as greater than or equal to. Ang HO natin ngayon is the hypothesized mean ay greater than or equal to 70. Ito yung kine-claim ng company. Ang HA naman natin is the opposite of the HO. If this is greater than or equal to, for HA, we will use less than 70. Since we have here a less than value for HA, we can say that the test is left-tailed. Again, we use the decision rule that I've presented a while ago. If less than ang symbol ni HA, then that is left-tailed. Step 2, let's solve for the critical value or values. We identify alpha, which is 2.5%. We transform this into decimal, so we write 0.025. So since left-tailed na siya, there is no need for you to divide the alpha. Iiwan natin yan as is. And then we will look for the t-value such that yung alpha niya dapat is 0.025. Tapos yung kanyang degrees of freedom is 49. Babalik tayo sa table at hahanapin natin yung t-value based on the alpha and the degrees of freedom. Andito tayo ngayon sa table. So, ang degrees of freedom daw natin is 49. So, let me scroll down to look for 49. Ito yung 49 natin. And ang alpha daw natin na gagamitin is 0.025. So, we just look for the third column dito sa ating highlight, this one. So, ito ang ating t-value, 2.010. So, we write here 2.010. But since we have left-tailed, ibig sabihin yan kung meron tayong normal curve, yung ating tail ay dapat nasa left. And we know na kapag nasa left ito, ang t-value natin should be negative. That is why we will just put negative 2.010. Walang problema kung right-tailed. We will leave this as positive. Pero dahil left-tailed tayo, we just put negative sa ating t-value. So let's continue here. Again, we have the following information. Now we are ready to compute for that test statistic. So again, T is equal to the sample mean minus the hypothesized population mean over S divided by square root of N. So ang X bar natin is 65.3 minus ang hypothesized mean is 70. Over 4 divided by square root of 50. So, doing the input in the calculator, ilagay muna natin yung 65.3 minus 70. And then, over 4 divided by square root of 50, the answer is negative 8.308 or negative 8.31. So, ito ngayon yung ating computed t-value. Sabi, sa ating decision rule kanina, we will reject HO if left-tailed tayo, di ba? Yung ating t-value na na-compute is less than the 3 critical. Ang ating t na na-compute is negative 8.31. Ang ating t critical is negative 2.010. So, obviously, mas maliit yung value ng ating negative 8.31 kaysa sa ating negative 2.010. So, ibig sabihin, less than siya, we will really reject HO. So, lalagay natin dito sa HO reject. At ang i-accept natin ay HA. So, for the conclusion, we can say that the mean of the auto batteries is less than 70 months. And to make a decision if the claim is valid or invalid, again, ang claim natin is the null hypothesis and we reject it. Dahil ni-reject natin yung claim, we can say that the claim is invalid. Ganun tayo mag-decide based on the acceptance or rejection of the null hypothesis. Doon nakabase if claim is valid or invalid. In the event na inaccept naman natin yung claim, then we can say that it is valid. Pero as we can see here, kitang-kita naman that we are rejecting the claim or the null hypothesis. So the claim is invalid. Let's go to another example to discuss further itong ating one sample t-test. So example number 2, 2 years ago, it was estimated that the average age of all CEOs of medium-sized companies in a certain town square was different from 57 years, and it follows a normal distribution. Out of curiosity, a certain person surveyed 15 CEOs in the said area, and she found out that the mean age is 53 with a standard deviation of 3 years. Using 1% level of significance, can you conclude that the mean age of all CEOs in Magic Town Square is different from 57 years? Tulad ng ginawa natin kanina, we will identify the different variables. You may pause this video after 5 seconds at alamin natin ang mga values ng mga variables na ito. Ang x-bar natin is yung mean ng sample. So, si Jane, nag-sample siya. Ang mean age daw is 53. Ang hina-hypothesize or ang kine-claim sa population is 57 daw, yung mean. Ang S naman here is the standard deviation, which is 3. Ang N naman here is 15. Take note that if we have less than 30 as the sample size, we have to check if the population is following a normal distribution. And we can see here sa ating first sentence that it is indeed following a normal distribution. So we proceed with the rest of the solution dahil tama naman no normal distribution naman daw ito. Alpha natin is 1%. And ang degrees of freedom natin here is n minus 1. So that's 15 minus 1 or 14. Let us set up the hypothesis, HO and HA. Ang HO natin, let's look back at the given. Ang kine-claim ng company ay different. So, ibig sabihin ng different, it means na this is not equal to. At ang not equal to ay ginagamit sa HA. So, ilagay muna natin dito yung claim. Different daw siya sa 57 years. Ito ngayon ang ating claim. So, pwede po yun, no? Hindi palagi na HO ang claim. Pwedeng HA yung claim. Depende sa keyword sa problem. Dito, dahil different, it means not equal to. So, ang not equal to ay para sa HA or sa ating alternative hypothesis. At yun yung kine-claim naman natin. The counterpart of HA not equal to is HO equal to 57. And because we have equal to and not equal to in our hypothesis, ang ating test is two-tailed. Let's go now sa critical value. Ang alpha natin is 1% or 0.01. But we have two-tailed test. Ibig sabihin ng two-tailed test, kung meron tayong normal distribution, andito yung isang tail, andito yung pangalawang tail. So, ang gagawin natin sa alpha, kapag two-tailed, we will always divide it by 2. So, ang alpha ngayon natin over 2 is 0.005. Ito ngayon yung gagamitin natin. Ang degrees of freedom natin is 40. That is why when we go back to the table, we will look for T na ang alpha over 2 is 0.005. Ang degrees of freedom ay 14. So, let's go back to the table and look for this critical T value. Andito tayo sa table at ang ating DF ay 14. So, ito yon. Ang ating alpha ay 0.005. Ito yon. So, ibig sabihin ang ating T value ay this one. 2.977. So, yan yung kukopyahin natin sa ating slide. Recall that you have two tails here. So, the left tail is negative 2.977 and the other one is positive 2.977. So, dalawa ang ating critical T values, negative 2.977 and positive 2.977. Let us now calculate the t-test statistics. So, we have here T, mean over hypothesized mean is divided by square root of. So, for the mean, we have 53. Ang hina-hypothesize natin ay 57. Ang ating S is 3 divided by square root of 15. So, make sure na tama ang pag-input sa calcu, lalo na at maraming involved na variables. 53 minus 57 all over 3 divided by square root of 15. So, ang t natin is negative 5.163. Or we can also use negative 5.16. So, step 4 tayo. We will reject HO if, since two-tailed yung test natin, absolute value ng t na na-compute is less than the t critical. So, ang t na na-compute natin is negative 5.16. We get its absolute value, so tatanggalin lang natin si negative. This is 5.16. Pero ang critical natin, ang gamitin natin yung positive na para kumbaga ay na-absolute value din natin siya. So, 2.977. On the other hand, dahil mas malaki itong 5.16, in absolute value kasi natin siya, this is greater than 2.977. So, ibig sabihin, we will not reject HO, but we will accept HO. Hindi kasi na-meet ng ating computation itong ating rejection region. So, hindi tayo magre-reject ng HO kasi greater than yung ating computed. So, what we can do is we will accept HO and we will reject HE. So, ang step 5 ngayon natin, ang i-conclude natin ay yung inaccept natin, which is the HO. The mean or the average age of CEOs is equal to 57 years. At dahil nireject natin ang ating claim, we can say that the claim is invalid. Again, hindi palaging invalid ang claim. Possible na maging valid yung claim kung inaccept natin yung hypothesis na kine-claim ng problem. Nagkataon na sa ating example 1 at 2, ang kine-claim ng problem or ng population ay yung hypothesis na nireject natin. So, I hope na intindihan kung paano nakuha or ginagamit itong one sample t-test. It's quite similar sa z-test, pero ang kanilang difference is si z-test may population standard dev. Pero si t-test, since wala siyang population na standard dev, ang ginagamit niya ay yung sample standard deviation.